Unite beyond boundaries. Innovate together. Joe's PANKRATION 2024. No border.
Hi, everyone. Thank you for joining my talk. My name is Shaoyi Li, and I'm the community hero from a Great China region. And I'm currently the lead cloud engineer at a payment company. I have been responsible for designing the compliance and security solution for our cloud payment system for many years, with a primary focus on the PCI DSS compliance. Before my talk, I would like to introduce the PCI DSS standard to you to help you better understand my talk. PCI DSS is a financial security standard to protect the cardholder data during the transaction process, transmit, and storage. And today, I'm going to talk about how to harness Amazon Bedrock to create a knowledge base for PCI DSS assessment. In my talk, I will introduce the challenges in compliance assessment from a compliance engineer perspective, and we will dive deep into how to resolve those challenges by using the compliance knowledge base. And third, we will learn how to build the compliance knowledge base on the AWS. And finally, I will show some results of my demo. And okay, let's start. Many of you may know the PCI DSS 4.0 became mandatory on April 1, 2024. There are around 63 new requirements were added. So we need to learn those new requirements to better understand the PCI DSS 4.0. Also, there are around over 400 requirements in the PCI DSS security standard. We need to spend a lot of time in understanding those documents. Next, after we grasp the content of the PCI DSS, we need to map the PCI DSS requirement to the company's internal compliance framework. That's to find the security controls we already implemented. In this process, we rely on the manual checks of the PCI DSS requirements, which is not very efficient and prone to human errors. And after we find the mappings, we need to collect the organizational policies, security operational processes, and security configurations to perform a gap analysis to find the gap between the system security posture and the PCI DSS standard. The challenge is hard to perform a very standardized gap analysis because everyone's understanding to the PCI DSS standard are different. And the last challenge is the repetitive compliance assessment, because when we deal with the compliance assessment from different customers, their audit requirements are mostly very similar and overlapped. So it takes us too much time in the similar tasks to do the repetitive tasks. And before we introduce our solutions, I want to introduce a little bit about the traditional assessment process. The process includes several different phases. The first one is gap analysis to find the gap. The second is to do a risk analysis to do a summary of the risk. And the third one is to have a remediation suggestions for those gaps. And the last one is to make a remediation plan. This is not a one-time effort. It's a continuous process to continuously remediate and assess. And the last step of the assessment process is to do the governance to make sure our cloud system is in the security posture. And I think about those processes are time-consuming. What if we use the Gen AI to resolve those challenges? So I think about empower those processes with Gen AI. So I think I have a solution to harness AI and rack knowledge base to make the assessment automated and standardized. This transform will help us to focus on the strategic decision making rather than the repetitive manual tasks. Okay, let's come into our solution. Before I introduce my solution, I want to acknowledge the contribution of Takehiro Suzuki at AWS Japan because he provided us a open source GitHub project. The name is Bedrock Cloud Chat. We utilize this open source project to build our knowledge base. We can see the architecture of the knowledge base. It includes several different modules, such as the authentication. They use Cognito to do the user authentication and authorization, and use the CloudFront with the S3 bucket to host the static web resources. And they also use the API gateway with the Lambda for the backend API and streaming response API. The backend API is to create the chatbot, create the knowledge base. And the streaming API is to interact with the knowledge base to reduce the response latency when we interact with the knowledge base to get the response. And they use the Amazon Bedrock for the LLM managed platform. We use the Cohere and cloud models on the Bedrock. And all the documents are stored in the S3 buckets. Once the user creates a chatbot, it's called backend API, and the API will trigger the event bridge pipelines to process the documents and embed, vectorize those documents with the Amazon ECIs and store those embedding vectors into the Amazon Aurora Postgres PG vector. And let's see the solution advantage. The first one, this is a fully managed serverless architecture. We don't need to worry about scalability and manual operation of the infrastructure. And the second one, the knowledge base is a private knowledge base. And all the data is in a private S3 bucket, and we send the private network access to the Amazon Bedrock. That's to ensure the customer data privacy. And third one is this solution is applicable to the multi-cloud and on-premise environment. We can load the metadata from different cloud providers and documents of the on-premise environment. So we can use the knowledge base to query the question about the multi-cloud and on-premise environment questions. And fourth, we can see the solution incorporate the batch compliance assessment with API. So we can address the challenge of the repetitive tasks. We can batchly answer the audit questions from various different customers. And another key advantage is this solution is one-click easy deployment solution. So we just need to run the CDK deploy. So everything is set up. It's very efficient, reduce a lot of workload. And sixth, this solution supports multiple model series, such as the Cloud and Meta Llama, and Cohere, and Mistral AI. We can select the appropriate AI model based on our use case. And in this slide, I will introduce how to build a complex knowledge base. Our goal is to load various data to restore the complete cloud system. We will rebuild the cloud system with different data source and have a whole picture. And the first kind of data is the CloudFormation IAC metadata. We use the IAC generator in the CloudFormation to get the metadata of the system configurations, and we load into the knowledge base. And the second one is the PCI DSS v4.0 standard document. It provides the compliance requirements, the standard. And the third one is the architecture and system data flow documents. It helps the knowledge base know our business and details of the system better. Sometimes when we set up the security group, the knowledge base can't check it well without some business information, such as which protocol, which security port we need to open. By this way, we can let the knowledge base better understand it. And the fourth one is the AWS official guide, compliance guide. It provides the best practice of the remediation and provide us with the remediation suggestions. The next one is the SecurityHub security finding list. It provides us the existing findings the AWS found and the associated risk scores. It will help us in the risk analysis in this case. And the last one is our company internal self-assessment and security remediation tickets. It provides us what kind of security finding we already resolved and what a whole picture of the current security findings we have in our ticket system. And for the LLM, we use a Cloud 3 Sonnet because this model have a balance of the cost and accuracy. In our benchmark testing, we find it has the best performance. For the embedding model, we use the Cohere multilingual. It supports more than 100 different languages, and it will fit our case very well. For the prompt engineer, we use the 3 shots COT methodology. In this COT prompt, we define the context. The context includes the customer's question and the role we define for the knowledge base, which is a compliance and a security engineer. And the AI will know it will perform a task of the compliance and the security engineer. We also define 3 tasks, like the knowledge base to do the compliance assessment check. The 3 tasks are the compliance check, the risk analysis, and the remediation suggestions. We also provide 3 examples to help the knowledge base better understand its task. And finally, I want to introduce the results we have. I take one question as the example. The question is about the PCI DSS requirement 1.3.1 and 1.3.2 is to check if the inbound of outbound traffic to the cardholder data environment is restricted to the necessary traffic. If the settings is the business-based. And we can see from the result, the knowledge base gave us the response. The response is, firstly, the response gave us the complex track result, which is no. It also gave us the details of the complex track. There are 2 parts. The first part is the inbound access, and the second part is about the outbound access. It maps to the 2 different PCI DSS requirements separately. And the next response is about the risk analysis and the remediation suggestions. You can see the knowledge base gave us a risk analysis based on the possibility, impact, and the number of sites. It gave us a risk score, which is high. This result is based on the AWS Security Hub. And the knowledge base also gave us a potential impact analysis of our security finding. And at last, it gave us the remediation solution to help us to remediate our security finding. It gave us the details and the steps how to resolve the issues. And you can see the last step is relevant PCI DSS requirements. That means if we resolve this kind of requirement, and what other PCI DSS requirements we can resolve as well. So it's a very comprehensive solution. So this is all my talk today, and thank you for joining my talk, and thanks to the hard working of the PANKRATION committee team. Thank you very much. You can scan the code or add me through the LinkedIn by the LinkedIn ID. Thank you.